Neboli rozhraní.
Takže napřed se zeptám, je tady někdo, kdo nerozumí anglicky? Já vím, že už tady pár předřečníků bylo. Okay. So the thing is, I've given this talk before, but never in any other language than English. So I would be very uncertain if I was forced to do so. So if you permit me, I'll stick to English for this one as well. So as has been mentioned, my name is Linton. This is where you can yell at me if you disagree with me. And this is about designing a Pythonic interface for Python libraries. So this is not this is an API design the way I see it, but not as an API as in like a REST API or something like that. This is code design and how to make libraries that will feel like Python and will allow people to use it. And whenever we talk about Python and design, there's one thing that needs to be mentioned, and that's literally this. So if ever you tried it, if you open a Python interpreter and you just type import this, it will give you something that's called the Zen of Python. And it's essentially a set of guiding principles that Python itself follows, but also that any code that should belong and has ambition to be part of that ecosystem should follow as well. So this is sort of my take on interpreting those rules and how to make them work and how those abstract rules actually manifest in real Pythonic code. So the examples I'm going to be using for this comes from my work. I work for a company called Elastic, which is a company behind Elasticsearch, and I was hired to essentially develop a library to allow people working with Elasticsearch. Knowledge of Elasticsearch is not important or anything like that. It's just something that I'll be using as examples. So it definitely helps. So, as I said, this is all about the Zen of Python. If you want to know all of the lines, I'll mention some of them. Just import this into your Python interpreter, and you will get, worldly sage advice that is completely incomprehensible. And hopefully, this talk should help a little bit with at least explaining how I see it, what I think that the Zen of Python actually means, and how it can be used to decide real-life problems, and not just, theoretical ramblings over beer. And of course, every good talk has a disclaimer. All of the opinions are my own, and also, do as I say, not as I do. I have done plenty wrong things, even in some of the libraries and examples that I'm going to cite here. It's more of an inspirational talk. It's not lessons learned. I still haven't learned them. I'm working on it though. So let's start with the very beginning. With an API. So what is actually an API? So we are used to talking about APIs nowadays when it is some interface to a service. So we say that Twitter has an API, Facebook has an API. But generally, it is a service for code. So whenever you want to interact with anything in code, that's what API is. That's what API means. So it's an interface that fulfills some contract. Essentially, saying, hey, I have some functionality here, and I want to make it available to you. And these are the ways how I do so. These are the exact steps, this is the exact interface how you can actually use my services. And those services are often external, like the aforementioned Twitter API. Or they can be internal, like in your Python code. So the Python standard library, for example, it has a huge API. So that's the kind of API that we're talking about. And the important part here is the contract. It sort of sets the expectations. What do I need from the API? What is the API supposed to do? So in some cases, again, the external APIs, it's pretty clear cut. Hey, Twitter is a service for posting tweets, so that's what you expect that. But what if you have something that's not that well defined? Something that's vaguer? No, it's just looking at that word seems wrong, right? It's difficult to work with. It's difficult to define. It's even feels wrong to say it. But that's often what the APIs are, because you don't have a strict definition of what it's supposed to be. There's room for interpretation. There is room for different opinions and for different approaches. So for me, when I think of an API, this is what I think of. I want to simplify access. I want that access to the functionality to be easy. You don't need an API. You can always do it yourself. Python is Turing complete. You can do absolutely anything, by definition. You don't need other people's code. Sorry?
Except uncomputable things. Never mind.
Never mind. Let's go with that one. So, you don't need libraries. You don't need the standard library. You can code everything yourself if you feel so inclined. But typically, you don't want to do that. And the single goal of the people designing those libraries are that you don't even want to. That you never feel the need to go and reinvent the wheel for yourself. That you're always more comfortable just using the code that's already there and trusting the people who do it. So these are our first two lines from the Zen of Python. Simple is better than complex. And complex is better than complicated. So those are the two lines that, to me, mean that we're simplifying access. So let's see a concrete example. So this is a valid Python code that runs a query in Elasticsearch. So what I'm looking is, I'm looking over some documents in my index where the title has something to do with Python. It doesn't have the word beta in the description, and it needs to be in the category search. And then I'm running some aggregation. I want to see how many lines there are and the distribution across tabs. What it does, it's not really that important. I don't expect you to understand this. I just want to say that this has some meaning in the language of Elasticsearch. And it's ugly. Nobody wants to sit down and write this. It's painful. With all the curly braces and quotes and everything, you feel like writing a list. Like, trust me, before I created this, I had to count these several times.
JSON.
Exactly. It is just JSON. And also, just to access the response, there's some magical parts, like, why is there hits twice? Like, this is actually working code, and it actually needs to be there, and there's a good reason for it to be there, but why should you care? That's what I mean by the complexity. There is some complexity that is not important. There is some complexity that is, however, very important. And those are two different kinds of things. So this is what I came up with as an interface for that instead. Essentially, the language that I used to describe what that code does is the only things that I should be thinking of. I shouldn't have to think about other stuff and curly braces and quotes, etc. No, I want to say, I want to filter where the term, I want to use a term filter on the category that is search. And there shouldn't be anything else, there shouldn't be anything on that line that I would not pronounce if I'm describing this to someone. Then I want to do a match query on the title where it should be Python. And then I want to do some negation here, I want to filter something out. And here I want to do my little aggregations. And also I just want to iterate over it. I don't care whether it's hits, or just hits, or something in between. I just want to iterate over things. So this is what I came up with.
How do you pronounce the tilde Q?
Invert. So the tilde in Python is called the inversion operator. So that's the inversion operation. So the first thing that you notice that there are plenty of things that I left there from the original things. It could have been clearer. Like when we actually look at it, there are still some things like the term match, what are those? It turns out that those are actually very important for Elasticsearch, and that's why I left them there. Because I want it to be explicit. I don't want to hide things from you. So this is another line from the Zen of Python that sort of embodies this principle. Like, there should be no hidden surprises. So in this case, how do you decide what do you hide? Because I've hidden a lot of things. But what do you keep? What are the important parts? So, to me, the guiding principle is this. Hide the mechanics, not the meaning. So, the meaning is what I said out loud. I'm looking for a document where the title matches the word Python. So that's the words that I still have in my code. What I don't care about are the mechanics. That there's some query and bool and must not and filter, and what are the differences between those and how do they fit together, and all this JSON crap and the hits and underscore score and underscore source title. I don't need that. I don't want that. Those are just implementation details, just mechanics. However, is the meaning. The stuff that I left there is the important part. Like that, you have a difference between term query and match query in Elasticsearch. You don't have to know that. You just have to trust me that there are huge differences in how they work and what they do. So you don't want to hide that. At least I don't want to hide that. Even though this means that nobody can use this API who doesn't understand Elasticsearch. That's not my goal. I don't want Elasticsearch to be accessible to everyone. I'm perfectly fine with people having to learn something to use this. Because only then will they get good results. Only they understand what they're doing. I could try and guess based on the type of the field and the type of the parameter. And for example, this I could automate. But then it would be very difficult to reason about the code. So that's why I left those. I still force people to know the difference between a match query and a term query. And then there is such a thing as a score, and it's a meta field, etc. So that's one thing. So another thing is to sort of admit to the leakiness. Don't try and pretend that this is something special. This is not something special. All this does is under the hood, it puts together the horrible JSON that I showed you in the beginning. That's it. And you can get it back if you want to. You can just call to dict method on it and get the raw dictionary, get the raw data, and then pass it as you would otherwise. So that's what our first API looked like. We just called client.search and gave it the horrible body. You can still do that. It is very clear where each layer begins and ends. This part of the API, that's just there for convenience, but in reality, this is the meat. Sure, there's a helper method on there. If I just start iterating over it, I don't need to execute it directly like that. But the code needs to be there. Also, I need to have a way for my advanced users, for example, to drop down if they care enough. Because maybe I won't be able to support the entire breadth of APIs that Elasticsearch has available. I will only implement the ones that 90% of people care about. I need to give the people who need the remaining 10% a way to access it. So in this case, all you have to do is drop down back to the low-level API. Similar concept that people might be more familiar with is Django allows you to pass in a SQL string if you need to. You have the .raw method on your query set, where if you want to do something fancy and something smart with SQL that Django doesn't allow you to do directly using its API, you still have a way out. You don't have to decide, hey, either I use Django or I use SQL. No, I use Django, and for the one tiny little use case where that's not good enough, I can still use the raw SQL. So that is important. And also, I'm not quoting the Django example by accident, because that's another thing that can help you create a friendly UI, and that is be familiar. Again, we have the representing line from the Zen of Python, and what I think by this, like, people should not be surprised by what they see. Also, many people here probably were not surprised by some of the syntax here. The way that things chain after each other. Like, that's something that I just copied shamelessly from the Django query set. Like, this is what Django does. And this is what Elasticsearch does. So all I had to do is take those two together, put them in a collider of some sorts, and see what comes out of it. Because people are already familiar with this. And people are familiar with this, or should be, if they want to use Elasticsearch. So, by sort of showing them how things were put together in the first place, saying, yeah, I just use whatever principle Django does, then it allows people to reason about the code, and they will never be surprised. They will never have to look up the documentation, because it's something that's familiar to them. And that's very important if you work with code. You don't want to be constantly surprised. Which brings us to the next point. Stick to it. Be consistent. If you choose something, just use it all over the place, so that people don't have to shift in their brains, hey, now I'm using this part of the API, now I'm using that part. So again, the line from the Zen of Python is, special cases aren't special enough to break the rules. Like, try to stick to it no matter what. Well, don't do it no matter what. The Zen of Python also tells us this. Practicality beats purity. Like, consistency for the sake of consistency is not good enough. There needs to be a reason behind it. You must not shoehorn things into places and shapes that they were not meant to be, that doesn't feel natural. And if you really noticed the example, it shows as well. You notice here I'm always assigning back to S. So every method call here actually returns a clone of the object that has been modified. And the original search object remains unchanged. And that's super useful if you're passing things around. But for some parts of the API, here defining the aggregation, it doesn't make sense. And there was other pattern that made more sense, and that is that when I define one aggregation and I want the other one to be inside of it, I just want to be able to say .bucket, .metric, and chain it like that. Which means that the thing that I'm returning cannot be the search object. It needs to be something else. So this pattern doesn't work. I just had to do something else. And that's okay. It's inconsistent and it causes issues, absolutely. But it's the better alternative than to trying to shoehorn this pattern everywhere, even though it makes no sense and there are other ways that feel more natural. So another advice, always be friendly. Think of how people use your library, how people use your code, and adapt to it. For example, one of the biggest advantages of Python is it's interactive. You can just start Python or IPython and just work there, explore the API, and run things line by line. Honestly, for me, that's how I work. If I get a new API, if I'm working on a code that's not familiar to me, that's what I do. And as an author of the API, that's something that you need to explicitly support. There are some helper methods and functions that are super important to make this work. Things that enable tools like IPython to do proper autocompletion. Things that allow proper introspection. Things that provide documentation. like this part. The Python ecosystem has been designed for this kind of use case, so that you can just poke around and experiment with the API. You don't have to sort of sit back and come up with all the code before you put, so to speak, pen to paper. Which is sort of sum up here. You want to be able to build things iteratively. You don't want to force people to always sit down and say, hey, so what is it that I need to do in the end? No, that's not how people work. That's not how computers work. You need to go one step at a time. That's how you think of the problem. And sure, if you can always say, yeah, one step at a time, just iterate on that piece of code until it's perfect. But it's much better if the code itself actually supports this. Where if you actually take the example that it's all the one same example that I've been using all over. And if you actually annotate it like this, if you use some wild thing like comments in your code, then this makes perfect sense. Filter only search. We want Python at the title, etc. And now even someone who's not familiar with it can read it. And you can kind of see how you could come up with this. Because you start with just one. Then you add another one, a new set of requirements. You can easily imagine that some of them would be conditionals that will not be run every time, but only if certain conditions are met. Like if the user checked the checkbox that they are only that they only care about the search category, etc., etc. So allow the iterative build work with the nature of Python. And finally, when we're talking about being friendly, friends keep each other safe, right? So the code should also be safe. The defaults, if the user is new to your code, they shouldn't do anything terrible. So if there is an option, for example, to make something safer or not, the default should be to make it safer. So always, for example, raise errors if a single tiny little thing goes wrong. Sure, sometimes it makes sense to allow people to override that behavior. But by default, you want it to be as safe as possible. And again, we have our Zen of Python here to guide us. And finally, tests. Like, think of how people are going to use your code in tests, in their tests, in your tests, etc. Give them the tools, for example, to set up an environment, an isolated environment, and run some tests against it. Some sort of sandboxing or anything like that. And use that code yourself in your tests. This is super important, and that really helps people to make them successful, to do things right from the very beginning. If you documented that, hey, welcome to my library, this is how you run tests, this is how you use the library in tests, this is how you use the API in tests, then you've short-circuited weeks of progress where people are trying to figure things out. Super important stuff. And be flexible. API is still code. Some people believe that like APIs mustn't change. Like we need to chisel them into stone and never touch them again. But it's still code. It's just like anything else. It's just like tests or documentation or any other piece of your project. It changes. It changes. It evolves. It evolves because you've come up with a better idea. It evolves because the situation has changed, etc. And that's okay. As long as you do it nicely, that's why we have versions of software, that's why we have helpers for backwards compatibility, etc. That's fine. Just things change. Just adapt to it. And fix it. Don't be afraid to. Remember that no code is perfect. So if you're stuck on one particular piece of API, whatever. Consider releasing your project without it. Maybe it's not needed. Maybe you can just provide a fallback and just say, hey, everything over there, I'm happy with. This part, I'm not happy with. You still have to do it yourself. This is how you would do it. I'm not happy with it. I'm working on it. Or you just say, hey, let's try this way, and then we'll see. So again, ZenF Python, now is better than never. But sometimes never is better than right now. If you don't know how to solve it right now, it's okay to say, we'll see. Like, people understand that. And that's it. That's everything that I know. That's everything that I've learned. And some things that I have yet to learn, and I'm still working on it. So if you have any questions, now would be the time.
Can you go back to the slide with the many comments?
I don't know.
Yeah. When you were talking about that, you
Yeah,
put in a lot of comments.
the iterative build. This one.
Yeah, this one. The other day, when I finished my script, I put so many comments, maybe like to each of the lines, so that in a few months I would understand what it does and remember. And I felt really weird about that because it doesn't look like code that we were taught to do, maybe. But then the next day, my colleague asked me about the code, about the script, and I could give it to her, and she would read it, and she would understand every line, even though she doesn't do any programming. But thanks to the comments, she would know what it does.
That's awesome.
So I was
That's
really
a sign of good code.
that I'm a total beginner, but I could actually teach someone who does no program at all to understand the script. So
Awesome.
this makes me happy.
Awesome. Yes. Absolutely do this. I try to do it even on the library code because I know that me myself, if I'm trying to use a new library and it is open source, I typically go read the source code even before I go read the documentation. That's just me being weird, and also that just internalizing that my documentation sucks. So maybe other people's documentation suck too. But that's why I even have comments like this inside the library. So absolutely. It is still like a large question how to write the comments and when to write the comments. You don't want to have comments like, hey, I'm incrementing I by 1. That's not useful. But if you say, I need to compensate for the border, so I'm adding 1, that's an absolutely different animal. So, as with everything, there is a right and wrong way to do it, but as you can see, like, this is probably much easier for you to understand than all of the examples that I showed without the comments. Even when you don't know Elasticsearch. So, thank you.
Thanks.
On one C++ course, I once heard that we should comment not what it does, but why it does it.
Yes.
I think that it iterates one,
Absolutely.
raises count by 1, that's obvious.
Yes.
But we should, why are we doing it?
Absolutely.
Okay, this is a question for newbies, not myself. But if a newbie was reading your code and came across s.ags.bucket, how would they find out what ags does? They would go on Google and they would search Elasticsearch Python ags, or what would they do to find out what ags does?
So ideally, at least that's what I would do, and that's what I would encourage anybody to do, is take this, paste it in IPython, and then do s.ags. And press tab a couple of times and see what it suggests to you. Run the help on it and see the doc string. That's what I mentioned. That's what the interactive thingy was about. Like, poke around, see what's in there. And obviously it should also be documented in quite an obvious fashion. For example, in this case, this is the search DSL, which has a page in documentation where it mentions how to do aggregations. And at some point, I'm hoping that somebody will figure out that ags mean aggregations.
Now we do.
Awesome.
Usually I have no problem like reading existing code, but like if I want to aggregate something, how do I find? If I want to aggregate something in Elasticsearch with this API, how do I find ags?
So, because, so first of all, you can read the documentation, it's all there. There are some examples. Yeah, you know that Elasticsearch does aggregations. It does this inside the search API. And you have a search object. When you define the aggregation in the raw JSON, in the raw dictionary, it's called AGS. So I assume that's what you would be looking for. By the way, you can also type aggregations, it will still work.
Oh.
I think I might be wrong.
Go fix it.
So that's one reason. That's what I meant with the be familiar. This should be very familiar to somebody who's done this the hard way. They should know what this is. They should know what this is doing. Like here, you have two weird strings. If you don't know anything about Elasticsearch, it's super weird. If you've ever constructed it yourself, you know that this is the name of the aggregation and this is the type. And then here are any parameters. So it should be familiar to somebody who knows Elasticsearch. That's how you should find it. You should be able to guess it because it's similar to the raw API. Cool.
Could you please scroll back to the example of special cases which are not special enough? The aggregation API versus.
Well, we don't need to scroll that. We see it right here in this case. It's always the same code. I only came up with one example.
Okay. My question is, why can't I use the first part, the filtering, as a fluent API? So the way search.filter.query.
You can, but you just have to remember to assign it back to S.
Do I have to?
Yes, because it doesn't modify the S, it creates a clone and modifies the clone.
And what was the reason?
So the reason for it is, imagine that you have a piece of code and you need to pass in a search. But then maybe you still want to use it somewhere else. So you want to be able to pass the S object to somebody else, have them do whatever, and then still be able to use it yourself without fearing that somebody modified it in place. And so that's one part of the answer. The second part of the answer, this is how Django does it. I'm not going to be smarter, and this is what people expect.
I think that the SQL ultimately does it the opposite way.
You can either do it that way or the other way. Ruby has an excellent answer for that. They have the banks for in place and without banks for a copy. Python doesn't have that.
Yep.
But be consistent. If you decide to do it one way, keep it that way.
Yep.
But this is super handy when you're filling the query, so you can comment out one row if you have like this button or in your fucker.
You're fucking right.
I was a little worried when Stefan raised his hand because he's the one person who actually uses that code. Okay, so I think we have time for one last question. Going once?
You
Going
can
twice?
chain filter query without assigning to S.
You need to assign to us eventually.
Just once.
Yes.
You can do S equals search.filter.query.
Yes. It would not be very, very nice. It would not be the iterative build.
Yeah.
And there's no need for it. You get nothing by it. It's just harder to read and harder to write. You need to fit it either on one page.
Shorter.
One line under
This is called the full readout. Yeah, you could, but it's harder to write.
You can also write in Pascal.
Okay, I think the time.